So is my screen visible to all of you?
Yes, sir.
Okay. So today I am seeing very less participants, but we cannot do anything. We have to start. It's already 6:11. So let's start the week 8 discussion. So myself Ayan Paul, PMRF research scholar from IIT Kharagpur, and this course Introduction to Soft Computing, taken by Professor Devasis Samanta of Department of Computer Science and Engineering, IIT Kharagpur. And today is 24th March, and we are, someone is joining. Okay, and today is 24th March, and this is the last week discussion of this discussion or problem solving session of this course. So I welcome you all. So let's start. So in the previous class, what I have discussed is we have started the neural network. What we have studied is function of a single neuron, and we have seen some of the neural network architectures. The three neural network architectures that we have discussed were single layer feed forward network, multi-layer feed forward network, and recurrent feed forward network. So up to that is okay, but what today we are interested in learning is that how the neural network learn by itself. So what is this learning process in the neural network that we are interested today. So in case of neural network, it is a process of modifying neural network by updating its weights, bias, and other parameters if any. So how a neural network learn? It learns by modifying or updating its weights, any biases that we are adding, or any other parameters. Now this learning usually takes place in different steps, and that steps we call it iterations or iterations. So when the neural network passes through different iterations, it updates its weight accordingly, and finally it reaches a weight that is at that weight and biases and other parameters, the error is minimized. So that is the concept of learning in neural network. Now during this learning, the parameter of networks are optimized, and as a result of curve fitting, you must have sorry, you must have studied in maths curve fitting. What we do is in the field, in field or actual data, what we do is we derive some input output relationship like x and y. X is your input and y is your output, and what happens is we have different data, like here we have one data, here we have one data, then here we have one data, some random data can be here also. This random data are called outliers. So in curve fitting, what we do is we try to fit a curve, like this 3 points are can make a good curve. So what we do is we pass a straight line with try to pass a straight line by all this on the basis of all these 3 points. So this is curve fitting, and then what we find out is R square, or coefficient of determination, and we try to find a straight line for which the R square is very close to 1, like 0.99, 0.88, 0.99, 0.97, more than 0.95, that we take care. So this is known as curve fitting. So this is a part of your linear regression. Now the neural network also learn in the same way, but I will tell you in a few minutes that how it learns. So basically types of learning, there are 3 types of learning. So one type of learning is known as supervised learning. So what happens is in this supervised learning is that we give input as well as we give output also. So you will ask me the question that if we are giving the output, then what is the use of a network? See, what happens is that this is the concept of supervised learning or learning with teacher. So when we are giving the input as well as when we are giving the output, the neural network learns from the output, like how much error is coming with respect to that input, and that is a process called supervised learning. So in this learning, every input pattern that is used to train the network is associated with output pattern. So we are giving both the thing. One is we are giving input pattern, second is we are giving output patterns. Okay, someone is joining. Yeah, input pattern, and we are giving output pattern also, or output data also. So we are giving input data as well as we are giving output data also. So this is called as training set of data. The output data is also known as training set of data. Thus in this form of learning, the input output relationship of the training scenarios are available. Okay, here the output of the network is compared with corresponding target value and error is determined. So what is the function of providing is output is that your neural network or any type of network that you are using that learns from this output data, and error is calculated, and then what your neural network try to do is it try to minimize the error after by training with some iterations. So after some iteration, the error will be very less, and that is how your neural network or any type of network learns. So this is known as supervised learning. So supervised learning, what I am currently doing is supervised learning only, means I am giving you both the input as well as I am giving you output also, so that your brain can learn from input and output. But after this learning, when you will be giving the you will be first when I am teaching you, you will learn something, right? And then you will apply that knowledge in the test, and in the test nobody will be there, only you will be tested. So that is how supervised learning works. So again I am telling, supervised learning is what? It is learning with the help of teacher. Like we are giving input data, we are also giving output data. Okay, someone is joining. Okay, so we are giving input data, also we are giving output data. So why we are giving output data? We are giving output data so that our network learn from the output data, that if one input is there, what will be the corresponding output. So by this your network learns, and your network whatever the network predict, some error is calculated with respect to this output data, and by this error your brain will teach to minimize this error, so that you learn in subsequent lessons, and then when you will be giving the test, you will be giving the test with minimized error or minimal error. So this is supervised learning. Okay, someone is joining. So this is known as supervised learning. Another type of learning is known as unsupervised learning. By name only it is you can pick up is that supervised learning is learning with the help of teacher. Unsupervised learning, learning without the teacher. Now you will say that if there is no teacher, how you will learn? Basically like if I will give you some data, some like some pictures of like mangoes, some pictures of apples, or some pictures of any other fruit like banana. So what your mind will do is, it will cluster the information. Like if you if you wouldn't even know that which is apple, which is banana, your mind will try to cluster same type of picture in one data set, and cluster one type of picture in other data set. So that is how you learn the things. Like if you have different data, like here you are getting some data, similarly here you are getting one cluster, similarly here you are getting one cluster. So your neural network or your brain, what it will try to do is, it will form the three clusters. This is first cluster, this is second cluster, and this is third cluster, based on the distance between the points. Like see, these 4 points are very close to each other, so here you will term it as one cluster. Similarly, these 4 points are very close to each other, this is the second cluster. Similarly, these 4 points are close to each other, this is the third cluster. So this is what we do in unsupervised learning. So here you can read, the target output is not available, error prediction cannot be determined, right? So the system learns by its own, discovering and adapting structural features of the input pattern. So you don't know which one is what, but what you will do is, you will just cluster the different types of data. So this is known as unsupervised learning. There is a third type of learning known as reinforced learning. Now supervised learning, it is with the help of teacher. Unsupervised, not with the help of teacher. What happens in reinforced learning is that there is a teacher available, but it will not give you the right answer. Like here in supervised learning, we are giving input as well as we are giving output pattern also. But in reinforced learning, we are only giving input pattern. So what the teacher will do is, teacher will reward the correct answer. Like if your answer is correct, the teacher will reward you. So by that you will understand that if this is a right answer or this is a wrong answer. So this is known as reinforced learning. The teacher will not tell you the correct answer, but what it will do is, it will give a award for the right answer, also it will give a penalty for a wrong answer. So by this you will learn. So this is known as reinforced learning. So is this slide clear to all of you? Am I audible?
Yes, sir.
Okay. So I think this slide is clear to all of you. Concept of learning and
Yes, sir.
three types of learning: supervised, unsupervised, reinforced. This is one of the most common question. If you are facing any exam, this is basically asked that what is supervised learning, what is unsupervised learning, what is reinforced learning. So I hope this is clear to all of you. Okay, so is my voice breaking? Someone is telling in the chat.
No,
No,
sir.
sir, it's clear.
Okay, okay. So very nice. So let's move on to the next slide. So learning, you got it. Now basically in this slide I have told you that how learning is done in neural network. We do it by updating weights, biases and other parameters. Now we will learn that how this weights are updated, weights, biases and other parameters are actually updated. So this is a diagram of a multi-layer feed-forward neural network. So let me tell you what are written in this diagram. So basically you can see three layers. This is your input layer, this is your output layer, and in between the input and output layer all the layers are called hidden layer. Here you have only one hidden layer. So one input layer, one output layer and one hidden layer. Now I11 means the input that you are given to the first neuron. So this is I11. Now when you are giving a input to a neuron, you will be getting a output from the neuron also, right? You are feeding some information to the neuron, so it will give you some output. So that output from the first neuron of the input layer is I01. I1 is, this is I1, not I11, I1, right? I1. So I1 is input input information of yeah, input of first neuron. This is I1. Then I01 input of output of the input neuron. I means capital I means that is input layer. We are talking about input layer. 1 means we are talking about first neuron, and O means we are talking about output from the first neuron in the input layer. So this is the terminology. Similarly you can also analyze for hidden layer first neuron. So hidden layer first neuron Hi1. H means we are talking about hidden layer neuron, right? 1 means we are talking about first neuron of the hidden layer, and I means we are talking about input of first neuron of the hidden layer. Similarly H01, H means again you can say that we are talking about hidden layer neuron, right? 1 means we are talking about first neuron of hidden layer, and output means O means we are talking about output of first hidden neuron. So this is how the terminology. Same thing you can analyze for output also. OI1, OO1. Okay. So up to this I think it is clear. Then weights. So what happened is that I have told you that all the information is all the information the information that is coming out from the first neuron of the input layer I01, that will not only go to the first neuron of hidden layer, that will go to all the neurons of the hidden layer. So that is why this I01, see we are attaching this I01 which with Hi1, similarly Hij, similarly Hin. So we are giving this input of first neuron of the input layer to all the neurons of the hidden layer. Now how much we will give, we will decide by some weights. So this weight is denoted here by V, right? So we all the information of input layer neuron is given to the hidden layer neuron by V weight. So how we will write it? We will write this as V11. That means first neuron is first neuron of input layer is attached to first neuron of hidden layer. So V11. Similarly here we can say that it is V1j. This line you can see that is V1j, right? V1j. because we are attaching first neuron of input layer with jth neuron of hidden layer. So Vij. Similarly, you can name all this, like this is Vin. Similarly, you can see here we can tell it as I. If we are connecting M with N, so sorry, V M N. So that is how you name this. Now again, the information that is coming out from the hidden layer will be going to the output layer also. So again we will have some weights here also. So when our input is connected to the hidden layer, the weights we are calling it as V. When this information of hidden layer is connected to the output layer neuron, we are calling it as W. And same way you can name it like W1K, because information from first neuron of hidden layer is going to kth neuron of the output layer. So WIK. So I hope the nomenclature is clear to all of you. Is it clear? Am I audible?
Yes, sir.
Okay, so I hope this is clear, right? Nomenclature of how we are writing this, right?
Sir, let me again, please.
Okay, sure. So there are three layers, right? One layer is input layer, the first layer is input layer, the last layer is output layer. In between all the layers we call hidden layers. Here we have only one layer between input and output, so this is our only one hidden layer. Okay, up to this, is this clear?
Yes, sir.
Okay. Now now I am talking about how these neurons are connected to each other, right? That is only we call architecture, right? Previously we have studied MLFNN, that is multi-layer feed forward neural network. Okay, so information will be only going in forward direction, that is feed forward. Okay, so we are giving one input to this first neuron, so that we are calling it I1. Why we are calling it I1? Because I for the as the neuron is an input layer, so I. Okay, so we are talking about I because this is the input end of this first neuron, right? There are two ends of a neuron, like this is a neuron, here one end, here one end. So this end we call it input end. It's like if this is a neuron of input layer, so we will be calling it I. Let it be first neuron. Okay, I1, right? This is I1, and this side we will call it IO1. Okay, so that is how we basically term the neuron. Okay, so this is the information that is coming from the input end, this is the information that is coming out of the neuron, and that is known as output of first neuron in the input layer. Okay, so this is the thing. Similarly, weights, like if this neuron, this is the first neuron of input layer, right? And this is first neuron of hidden layer. So now the output from this end, like IO1, that is that will not completely go to this input of this hidden neuron, right? Some portion will be going to the to the hidden layer. So how much portion is going, that we will be denoting by this V. So we will write V11 because first neuron of input layer will be connected to first neuron of hidden layer. So V11. Okay, so is this clear?
Yes, sir. Clear.
Okay, so similarly you can see
Yes,
here
sir.
also
Yes, sir.
W1K, like first neuron is connected to kth neuron, so W1K. Okay.
Yes, sir. Got it.
Okay, so I hope this is clear. Let me erase it. Okay. Now I have told you that like for this neuron, this input we know I1 and output, that is I01. Now how we will be getting output from this input? So for this we have several transformation function or activation function. So in this input layer what we are using is linear transfer function, that is y equals to x. So this is linear transformation function, that means I01 will be equal to I1 because we are using this function y equals to x. Now this hidden layer what we are using is log sigmoid transfer function. So log sigmoid you all know log sigmoid, e to the power minus alpha e to the power plus will be there and minus will be there, e to the power minus so that is this transfer function is tan sigmoid transfer function. Similarly log sigmoid very similar, only you have to do is 1 minus 1 by 1 plus e to the power minus alpha I. So these are the three transformation function used for three layer. So in the input layer what we are using is linear transformation function, that is y equals to x. In the hidden layer what we are using log sigmoid transformation function, that is 1 by 1 plus e to the power minus alpha I. And in output layer what we are using is tan sigmoid function, that is e to the power plus alpha I minus e to the power minus alpha I, e to the power plus alpha I plus e to the power minus alpha I. This alpha is some constant and I will be the input of this layer. Like for this hidden layer here in place of I what we will be writing is h11 or h1j or h1n. Similarly here also you can say that here in place of I what we will be writing is alpha O11 or O1k. So is this clear?
Yes, sir.
Okay. So up to this is clear. So you basically learn this. Now what we are interested in, how this multi-layer feed forward network is learning. So how it is learning? It is basically learning by a method called steepest descent method. Okay, steepest descent means we will be calculating gradient and we will try to find a gradient at which the minimum error will come. So now here what is happening is you are getting some output, that is okay. Now I have told you in supervised learning you are giving output pattern also. So that output pattern is known as target output value. So output value you are getting what your network is predicting, but you have some target output value. So this is a squared error, that is when you are subtracting the target with the output, target minus output whole square, this is the squared error, and this is known as mean squared error for all this output neuron, that is k to the power k equals to 1 to summation of k equals to 1 to p. Like if the total number of neurons are p, so we are adding all the error of all this neurons, and we are what we are predicting is the error from the network. Now when we have error, what we are doing is we are seeing that how this error is how this error varies with weights. So we have two types of weight, right? For this input and hidden layer connection we have V weight, and for this hidden and output layer connection we have W weight. So this is our graph, right? So in 3D, like V and W, if V and W are very same, so this is the graph, because this is two dimension, right? But if V and W have different values, like V have other values and W have other values, then we have this 3-dimension graph, right? So now what is our aim is that our aim is to our aim is to go from increment by increment. This is increment, okay? By increment to increment, our aim is to go here to reach this point. Why we are interested in reaching this point, or in this graph you can say our aim is to reach this point. Why we are interested in reaching this point? This is because at this point or at this point the error is minimal, okay? So that is how our network is learning. So you can see that a delta rule is for steepest descent learning. So how is this delta rule working? So delta V is minus eta del E by del V. So here in this graph you can see, like if let's for now let's forget V. Let's say that we are only dealing with this V, okay? So see, your when you are first increasing the V, your error is increasing, then it is reaching a global maxima, then again it is decreasing, it is again reaching a local maxima, and ultimately you are finding the global minimum error, okay? So if you are searching in this space, like up to this point, so in this point you can see that, sorry, let's, like you are only seeing this point, right? So in this point, if del E by del V, what is del E by del V in the graph? Del E by del V is the slope of the graph. So you are seeing that the slope of the graph is already increasing, right? So if we will be increasing in this part, if we will be increasing V, so our error will be increasing, but that we do not want, right? We want our error to decrease. So that is why we are putting a minus sign here, okay? So I hope you all got the significance of this negative sign. Again I am repeating, if this is your slope, right? This is the slope, so this slope is increasing. Like if we are increasing the V in this portion, our error will increase. That we do not want. We want, if we increase the slope, our error should decrease, right? So for that we are putting this minus sign. And what is this eta sign? Eta is a learning rate. So what is the significance of learning rates? Learning rate basically decided after how much or in which gap we are checking. Like if our learning rate is more, so we are checking this to this, means we are checking a more portion of the curve. But if our learning rate is small, then we are checking a very less portion of the curve, like this. So I hope you got how the formula is working. So is this clear?
Yes, sir.
Okay. So similarly for delta W is minus eta del E by del W, okay? Now when you are getting how much to decrease the del V and how much to decrease the del W, then you can update your weight. So your updated weight will be equal to previous weight plus this del W JK that you are just calculated, okay? So by this you are updating the weight. Similarly you can do it for this V also. Vij updated equals to Vij previous plus del Vij, means this is you will be have a previous weight, and when you are adding this thing delta V, you will be getting an updated weight. So that is how we update the weight. Now up to this I think it is simple. Is this clear to all?
Yes, sir. Sir, actually, those things are clear. What are the mathematically derived or those formulas? But now I did not got that. What is the steepest descent? Meaning, what is the meaning of that word?
Okay, steepest descent. Steepest descent means steepest descent. Descent we are using when we are using this differentiation. Okay, steepest like gradient
Yes, sir.
descent, descent. So descent when we are using this differentiation, or when we are talking about slope, that is known as descent. And steepest descent means when we are searching for our local minima or local maxima. So in this case we are, sorry, local not global maxima or global minima. So in this case what we are doing is we are searching our global minima here. Okay, so at which global minima or at which value of v we will be getting our least weight, least error. Okay,
Sir, actually, in this graph, what we are searching? I mean, we are searching for error.
we are searching, we are, what we are doing is we are trying to update the weight. Okay, we are
Okay, sir.
updating the weight, Vij updated and Wj updated. This is the graph, this is the relationship of weight with error. Okay, so basically what we are doing is with the help of this learning rate we are first defining our search length of this graph. Like this is our search length, this is the search length. At this search length what we are observing is when we are doing del E by del b, del E by del b is what, slope of the curve. So what we are observing
Yes,
is
sir.
the slope is actually increasing, but we don't want to increase the
Yes,
slope,
sir.
right?
Yes, sir.
We have to decrease the slope, so that is why minus sign. That means our slope is trying to increase in this way, but what we will be doing is we will be calculating delta v in such a way that our slope will be going in this direction. Okay.
Okay, sir.
Okay, so I hope this is clear. Now the question is how we will find del E by del V or del E by del W, right? So you can see that you cannot directly differentiate del E by del W because you don't have any relation of E with respect to W, right? Where
Yes, sir.
here you can see here we have error, right? After output we have after output we have predicted value or t. Okay, or we can say where was it? After here we are getting output predict sorry this target value or t. Okay, right? So your error will be in between your t. Okay and o. Okay, that is output of the kth neuron and target output of the kth neuron, right? So here you will be getting your error e in between o. Okay and t. Okay, but with error there is no direct relationship of w or weight of the hidden layer connected to the output layer. You don't have any direct relationship. So what you have to do, you have to use this chain rule. Okay, so first what we will do is we will associate this error with output. How we will associate this error with output? Similarly by this by this formula. Okay, error with output. Now output with output of output the information that we are getting from output of this neuron with input side of this neuron. So OOK with OIK. So that relation, how we will get that relation, we are getting by this tan sigmoid function. Okay, and then OIK with WJK. Finally we are reaching OIK with WJK. Okay, how OIK and WJK is related? We are just multiplying it, right, to get OIK WI1K into HO1 equals to your OIK. So this relation also we know. So that is how we will use chain rule to calculate del E by del W. Again I am repeating, what we are interested in calculating del E by del W. So how we will but actually we don't have any direct relationship of E with respect to W, right? So what we will be using is we will be using a chain rule. Like here is our error between this predicted output and this output. So here we have our error. So from here we will be first going to OK or this one. How we will be going? We will be going by this relationship. Okay. Then OK to OIK. How we will be going? We will be going by this relationship or tan sigmoid function. And then we know that O1 into W1K equals to O1K OIK. So by this we will be reaching to WJK. So this is how del E by del W is calculated. Similarly, del E by del V can be calculated by this way only. Like first we will be going from error to the output, then output or OOK, then from OOK to OIK, then from OIK to OK, then HOK or HO1, then HO1 to HI1, and finally HI1 to V. Okay, so this is the chain rule for del E by del V. Okay, so is this clear?
Yes, sir.
Okay, so let's see by a numerical example that will be more clear. So this is a numerical example. So here you can see we have three layers. This layer is input layer, this is the output layer, and this is the hidden layer. So in input layer we have 2 neurons, 1 and 2. In hidden layer we have 3 neurons, 1, 2 and 3. And in output layer we have only 1 neuron, 1. Okay, then two outputs are coming, I1 and I2, and outputs are given 0.5 and minus 0.4, and we are also given with target output. Target output TO is given here, right? What is the significance of this target output? By this target output we will be calculating the error. Okay, so TO is also given. Now this input layer is connected to the hidden layer by weights V. So this is V11, similarly V12, V13, similarly V21, V22, V23. Similarly you can see here W11, W21 and W31. Okay, so now for this input layer we have used this this function, or this is your linear transformation function, that is y equals to x. And for hidden layer what we have used is log sigmoid function, that is 1 by 1 plus e to the power minus x. Then for this output layer we have used this function called tan sigmoid function, e to the power x minus e to the power minus x, e to the power x plus e to the power minus x. Okay, so up to this, is this clear? Hello?
Yes, sir.
Okay.
Yes, sir.
Okay. Now your weights are also given. V11, V12, V13 is given, 0.2, 0.4, 0.3. Similarly, V21, V22, V23, these are given. Similarly, W11, W21, W31 is given. So weights are also given. So two inputs are given. Target output is also given. Weights are also given. Now what we have to do? It has been asked in the question that using incremental mode of training for the case shown in the table, calculate the changes in V. That is, we have to calculate del V, we have to calculate del W, and using back propagation of error that we have just learned, and learning rate eta is also given, 0.2. So only one iteration we have to show. So what we have to basically do is we have to calculate del V11, del V12, del V13, similarly all this, del W11, del W21, del W31. Okay, so is this clear? Question is clear, right?
Yes, sir.
Okay, so let's move on to the answer. So in any network you first have to do forward calculation. Why we do forward calculation? We do forward calculation to reach this output. We have two input, right? I11, I1 and I2, and we have to reach this O output. So for this we have to do our forward calculation. Means the input here will be giving some result here, then from here we have to move here, and from here we finally will reach output. So let's first see. So first it has been done for input layer. Now for input layer, the function they have used this y equals to x, that is linear function. That means I1 will be equal to we have like I1 will be equal to I01. So that is written I1 will be equal to I01, I2 will be equal to I02. So up to here I think it is clear. Now how we will be getting hi1. So hi1, so hi1 is somewhat here. So hi1 is made up of this v11 into io1 plus v12 into io2. So that is what written, io1 into v11, io2 plus v21. Similarly, you can calculate hi2, hi3. Is this clear up to this? Hello?
Yes, sir. Yes, sir.
Okay,
Clear.
so I think it is clear up to this. Now we have reached here, right? We have reached here. That is I
Error.
yes, hi1. Now what we will be calculating, ho1. Now ho1 is calculated by this formula, because in the hidden layer what we are using, we are using this transformation function. This is the log sigmoid transformation function. So you have hi1. When you will be putting hi1 in this formula, this log sigmoid formula, you will be getting ho1. Similarly ho2, similarly ho3. Okay. Now output, how we will be calculated? You have ho1 here, ho2 here, and ho3 here. Now output will be ho1 into w11, ho2 into w21, ho3 into w31, and by this you will be finally reaching the output, or oi1, right? We have till now we have reached the input end of the output, right? There are two ends of the output. This is input end. Now finally we have to reach to the output end of the output. So how we will reach to the output end of the output? We will be applying this formula, y equals to e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. That is tan sigmoid function. And when we are applying a tan sigmoid function here, this is our output. Okay, 0.195692. Okay, this is our output. But here you can see in the question, T is O, or our target output is given 0.15. So there is some error. Our target output was 0.15, but we are getting 0.19. So there will be error. So we will be calculating the squared error. Okay, squared error is calculated by this formula. I have already shown half TO minus O, whatever your output will be there, and your this is your error coming. So forward calculation, is this clear? This slide?
Yes, sir.
Okay, this slide, I think it is clear. It is very straightforward. Still, if anyone has any doubt, can ask. Any doubt up to this? Okay, so I hope this is clear. Now we will be doing the back propagation. Now we will be jumping to the error part. We had got our output, we had got our error. Now our target is to modify the weights that has been asked in the question. So how we will be modifying our weight? We will be modifying our weight by this formula that I have just discussed. That is learning rate into del E by del w, and as we are calculating for 1 del w11. So how will be get moving to del yeah. So again I have told you there is no direct relation of this error with w11, right? So we have to move from one step to another step, right? So your error will be somewhere like here. So first we have to move from this error to this output end, from this output end to this input end of the output, and then from this input end of the output to finally w11. So that is how it is written. Okay, so I have explained you in this theory part only. So this is how we write this. Now we will be doing we will be calculating this first, that is del E by del O1. You can do the simple differentiation, and that is coming TO minus O I1. This is the differentiation part. So by this you had calculated this. Now you can calculate this, or you can calculate this also, that is del O1 by del OI11. For del O, how del OI1 is related to OI1, that it is related to by this relation, okay, tan sigmoid relation. And when you will differentiate this, you will be getting this thing, okay, 4 by e to the power OI1 plus e to the power minus OI1 square. Okay, so this is also, second thing is also clear. Now we will be getting to a third thing. third thing, this HO1 is related to OI1, that is related to HI1, HOI1 into W11 equals to OI1. Okay, so third part is also cleared. Okay, so when you are getting this, when you are getting this, when you are getting this, by calculating all this, you are finally reaching del W11. So is this clear?
So those things have getting some value, or mean I think that there is no value. So how to calculate like this? I don't get this.
How to calculate what? Can you specify, please?
So actually there is the del E by del del O and these things.
Yeah, del E by del O1. So how you will be reaching del E by del O1? You first see how this what is the relationship of E with respect to O1. What is the relationship of E with respect to O1? This is the relationship of E with respect to O1. Okay?
Yes, sir.
Okay, now you can differentiate it, del E by differentiation. I hope all know, right?
Yes, sir. Yes, sir.
Okay, so O1 you can see, you can do it, and how it will be half into half into.
Okay, sir. Sir, after that.
Okay, have you got this? You
Yes, sir.
understood this? How we got this? Del E by del O1.
Yes, sir. Yes, sir.
Similarly, you can check for del O1 by del OI1.
Oh, okay, sir. Okay, sir.
Okay, and you can put the value of TO, you know. TO you know, right? Target output you know. This is your target output, 0.15, right?
Okay, sir. Okay, sir. Got it, sir. Thank you.
Okay. So you will be reaching this del W11. Okay. Similarly, you can calculate del W21, del W31. Okay. So your weights are W weights are updated. Del W11 you got, del W21 you got, del W31 you got. So finally you can use this formula. So you have got this del. Okay. Now we will be calculating the del V portion. We have checked for one iteration what is the change in weights we have to do of W. And similarly, we can check delta V11. Same formula, delta V11 will be eta del E by del V11. But now your chain rule will have 5 components. Earlier it has only 3 components because you have to move from here to here only. But now you have to move from here to this thing. So your chain rule will have 5 components. How? First it will be relation with E with respect to OO1. Okay, then OO1 with OI1, then OI1 with OH1, then OH1 finally to finally to IO1. So 5 components. Okay, so is this clear what I have told?
Yes, sir.
Okay, so similarly you can do the differentiation of del E by del O1, del O1 by del I1. Okay, this is the first thing. Second, this is the thing. Third thing is this. Fourth thing is this, and fifth thing is this. All value when you will put TO, when you will put OO, when you will put similarly W11, all this value when you will put, you will be getting this answer. Del V11 will be getting minus 0.00010. Similarly, you can calculate for del V21, del V12, del V22, del V13 and del V23. So we have got all this del V for all this, for V weights also. First we have calculated del W for W weights, then we have calculated del V for V weights also. Now we will be simply doing the addition part, right? That is this thing. WJK updated will be equal to WJK previous plus delta WJK. So this thing we will apply. So what was your W11? So W11 was 0.1, and now you are getting del W11 as 0.004526. So when we will be adding 0.1 with plus of minus 0.00425 then your updated weight will be this one 0.199890. You can calculate this 0.1 minus 0.004256, that will be equal to this thing, that will be equal to this thing, 0.095474. okay. Similarly you can do for W21 W31. Similarly for V also you have your what is your V11 was 0.2 and del V11 was minus 0.000110. So 0.2 minus 0.2 plus of minus 0.000110, you will be getting this 0.199890. So is this clear? Same you can do for V12, V13, V21, V22, V23. So is this clear?
Yes, sir. Okay, sir. But in Sunday exam, is there any question comes from this?
Your question will not be that big. I will be discussing what type of question can come. That I will
Yes.
be discussing in a moment. Your question will not be that big. Do not take tension. You have limited time. We all know. But this concept you should understand. So do you all
Yes, sir.
understand this concept? Whatever I have told,
Yes, sir. Yes, sir.
how we are updating the weights, that is very important. Okay.
Yes, sir. Okay, sir.
Okay. Now this last thing, hybrid system. So what we have done till all our weeks, we have started from genetic algorithm, then fuzzy logic, and then finally we have completed neural network. Okay. Now all these three things, that is GA, then FLC or fuzzy logic, and last is NM. Okay. All these things have certain advantage as well as certain disadvantage. So let's start with GA. GA has the advantage is that it will give you local minima, but it has the disadvantage is that GA has the advantage that it is a first of all it is a good optimization technique. Second, it will give you local minima, but it will not guarantee you global minima. Okay, global minima or global maxima. So this is the disadvantage of GA. Similarly, if you will see fuzzy logic, advantage is that fuzzy logic is very important in dealing with this uncertain variables and all this. The variables which have uncertainty in it, it is very useful fuzzy logic. But the disadvantages of fuzzy logic is that it cannot work if it has more number of variables. When your variable will increase, there are some limitation of this fuzzy logic. Now neural network advantage is that it can have more number of variables, as much variable as much you can give, like we are giving variable in terms of neuron, right? So as much variable as much you can give. But the problem of neural network is that the training time of this neural network is very large. So again I am repeating, all three have some advantage, but all three also have some disadvantage. So to counter this, what the scientists have done is that they have made hybrid system. Hybrid system is that you are connecting, you are trying to combine two things, or you are combining three things like GAFL, right? Combining, we are basically combining two things to counter the disadvantage of one another, right? GAFL, then GA, and then FLNN. And then GA, FLNN. Okay, so this is the combinations. Okay, so this is known as hybrid system. Okay, so is this clear what I have told you?
Yes.
Okay. Now thing is that hybrid system, sorry, okay, so hybrid system that I have told you. Now we basically do the hybrid system or join this network by three hybrid system. One is First one is sequential hybrid system. So what we do in sequential hybrid system is that technology are used in pipelining fashion. So in computer science, this pipelining thing is very popular. So what is this pipeline thing is that one technology output becomes another technology input. Okay, so basically we are combining, like if we are combining GA with NN, right, by this sequential hybrid system. So what we are doing is, first we are calculating output with GA, right, whenever we are calculating output GA. So let's say our output from GA is we are getting O1. Now we are using this O1 as an input for this NN. Okay, this output will be input for this NN. So this type of system is known as sequential hybrid system. Okay, so again I am repeating, what we are doing is we are using the output of one technology as an input for the other technology. So this type of system is known as sequential hybrid system. But one thing you must know, that this is the weakest form of hybridization, because ultimately when you will see that we are not fusing, or we are not combining one thing, we are just taking the output of one technology and we are using this as an input for the next technology. So this is the sequential hybrid system. So the modification of sequential hybrid system is auxiliary hybrid system. So what we do in auxiliary hybrid system is, one technology calls the other technology as subroutine to the process or manipulate information needed. That means when one technology, like example you can read a neurogenetic system in which a neural network employs a genetic algorithm to optimize the structural parameter that define its architecture. So what happened is that one technology, like this NNGA, right, NNGA, we are talking the example of NNGA. So this NN will take help of this GA only when it needs this GA. So when it needs the GA, it needs the GA to optimize the structural parameter. So this is known as auxiliary hybrid system. So this hybrid system is definitely better than sequential hybrid system, because this is an update form of this sequential hybrid system. Okay, now we have a third kind of hybrid system, or embedded hybrid system. Now what happens in this embedded hybrid system is that the technology participating are integrated in such a manner that they appear intertwined, like NNFL. Here we are completely fusing two technologies and then using it, like NNFL hybrid system. Here what happens in NNFL is that we are using fuzzy input to this NN architecture. Okay, so this type of system is known as embedded hybrid system, and this is the most popular one because we are completely fusing both the technologies. Okay, so these are the three hybrid systems. Is this clear?
Yes, sir. Clear.
Okay. So let's move on to the questions. So the questions will be discussed on this topics: artificial neural network, training 1 to 4, and soft computing tool and hybrid computing. Okay. So I hope everyone will be participating in the discussion. Okay. I want this session to be interactive one. Okay.
Sure, sir.
Okay. So this is the first question: which of the following statement is wrong about the learning technique in artificial neural network? And these are your 4 options. Option A is learning is performed by modifying the weights, bias, terms or other related parameter. B is learning is performed through multiple iteration or steps. C is many of the learning technique utilize gradient descent method to
Sir, option 4, learning is done by changing the number of hidden layers.
Okay, so you are telling D. Propagation is also telling D. Any other? Okay, someone is joining. Okay, so I am asking any other guesses? Any other option that you want to say which is wrong out of the 4? Okay, so I hope all are telling D. So yeah. Let's check one by one. Learning is performed by modifying the weights, bias, terms or other related parameter. This is absolutely right. Right? We have just now discussed the numerical also. What we were doing is we were modifying the weights. We do not
Oh,
have,
it's
yeah, we do not have bias in that question, but we were modifying the weights. Okay. Then learning is performed through multiple iteration step.
Sir,
That is also correct, because again you can see that we have done it for first iteration. Similarly, you have to do it for subsequent iterations. Okay, to reach the local minima of the error. Okay, so again this is also right, B. Okay. Now see, many of the learning technique utilize gradient descent method. So whatever we are discussing was gradient descent. That gradient descent means that is related to the slope of the curve. Okay, so C is also right. And D is learning is done by changing number of hidden layers of ANN architecture. When we are performing learning, one thing you have to understand is that we are not changing the network architecture. Okay, network architecture will be same, only we are modifying all the weights through iterations. Okay, so this is a false statement. And here we have asked which one of the statement is wrong, so option D is wrong. Okay, so is this clear to all of you? Any question regarding this question?
no, sir, clear.
Okay,
sir,
so
sir, in option A,
yeah,
what is the other related parameters?
other related parameters. Okay, so other related parameters, what can be the other related parameters? So yeah, question is good. So let's see other related parameters. So basically we are updating
Weight height.
basically we are updating weights and bias only. Okay, and other related parameters is actually when you are using like GA, that hybrid system, right? GA with this NN or this type of thing. There what we also do is, you can see this question, this where is the question one? Okay, you can see this question, right? This is e to the power x, e to the power minus x. Okay, this is the transformation function, but here alpha can be also there, e to the power alpha x, e to the power minus alpha x. So these are the extra parameters. Okay, some constant would be there in the transformation function, etc, etc. Okay, so that also by when we are combining other technologies with this neural network, that also we try to update. Okay, like the constant
Sir,
that is associated with transformation function, etc, etc. Okay,
sir, okay, sir. Here also one question, sir. Why we are using the log sigmoid function for hidden layer
that
and
is that is given in the
tan
question.
sigmoid for
Yeah,
any
yeah.
specific reason, sir?
No specific reason. Only thing you have to take care is in the input layer you always use a simple transformation function, like linear transformation function, or previous class I have told you hard limit transformation function, like that. Okay, input layer always use this simple transformation function. In the hidden layer what you do, you always use the complex transformation function. And output layer, it is up to your choice. You can also use this complex transformation function also you can use simple transformation function also. In the question it has been given, they have used tan sigmoid transformation function, that is a complex type of transformation function. Okay.
Okay, sir. Thank you, sir.
Okay, that is good. Now question number 2, which statement is true about supervised learning approach? So option A is in supervised. Okay, in supervised learning, the output pattern is not provided with input pattern. And B is in supervised learning, the ANN learns from the internal structure from the input data and without any help of output pattern class levels. C is supervised learning follows reward penalty mechanism for right or wrong prediction made by the network. And D is in supervised learning, an error is computed between true and predicted output pattern, and the network learns by minimizing the error. Okay, so what is the right answer for this? Any guesses?
Learning and error is computed. Yes, sir.
Okay, so D. Any other guesses? Anyone who wants to contradict this D and wants to tell any other option? Okay, Murugation is also telling D. Any other guesses? Okay, so yeah, in supervised, so let's check one by one. In supervised learning, output pattern is not provided. This is absolutely not correct, because I have told you supervised learning output data is also provided with input data. So this is not correct. Now in supervised learning, ANN learns from internal structure of input data and without the help of any output pattern. This is also false because we are supplying the output data. Supervised learning follows reward penalty mechanism for the right or wrong prediction. This is true for the third type of learning, that is reinforced learning. This is not true for supervised learning. This is learning with the help of teacher, but with a reward penalty mechanism and not with the help of output data. So C is also false. So answer D is correct, that is in supervised learning error is computed between true and predicted output pattern and network learns by minimizing the error. So is this clear? Okay, am I audible?
Yes, sir.
Okay.
Yeah.
Okay, now question number 3, which statement is true about unsupervised learning? So 4 option you can say. See, first is in unsupervised learning, the output pattern is provided with the input pattern. B is unsupervised learning computes the error between the input data and corresponding output data pattern. C is in unsupervised learning, network model learns the internal structural features of the data without the help of output pattern. And D is unsupervised training is used for classification between multiple classes. So any guesses for this? So any guesses for this? Murugation is telling C. Okay.
Yes, sir. Answer C.
Okay, so Sakti Savani Mahapatra is also C. So yeah, so let's check in unsupervised learning. Output pattern is provided with the input pattern. This is absolutely false because this is an unsupervised learning, so we are not providing any output pattern. B is unsupervised learning computes the error between input data and corresponding output data pattern. So you can see that again we are not supplying any output data, so error will not be calculated, right? So this is also false. Now in unsupervised training, the network model learns this internal feature of data without the help of output pattern. So yeah, we are not supplying any output pattern, it is learning from the internal structure feature of data. So this is a true statement. Okay, now D also we need to check. Unsupervised training is used for classification between multiple classes. So not exactly classification. If it was written clustering, so that is true. Clustering, or you can say grouping of different patterns of data, that is true. So as it is written classification, so classification you cannot do, you can just do clustering, that is you can put similar data in one group. Similarly you can put other similar data in other group, so that is also false. So C option is your correct answer. Okay, so is this clear?
Yes, sir.
Okay, so Hebbian learning is a form of, these are the 4 options available: supervised learning, unsupervised learning, reinforced learning, and stochastic learning. So any guesses for this? This you must have read in your lecture notes. Any guesses for this? Yeah, Murugation is telling B. Okay, so let me tell you the answer. So basically learning, I have already discussed, we divide the learning in 3 parts: supervised, unsupervised, and reinforced learning, right? Now there are in supervised learning also there are 2 forms. We have discussed this error correction or gradient descent method. There is another method called stochastic modeling, that you can learn about all this from your lecture notes. Similarly, unsupervised learning is divided into 2 parts. One is Hebbian learning and one is competitive learning. This you can learn more from your lecture notes. So your question here is, Hebbian learning is the form of what? So Hebbian learning is a form of unsupervised learning. So option B is your option B is your correct answer. Okay, so this I am not discussing in detail. More details you can learn from your lecture notes about Hebbian learning. Okay, now question number 5: in which learning method in the following those neurons which responds strongly to the input stimuli have their weights updated. So any guesses for this?
Competitive learning, sir.
Yeah, so I have just shown you the thing. I have just shown you this graph. So you can see that unsupervised learning, Hebbian learning, and competitive learning. And in competitive learning, what happens is that those neurons which respond strongly to the input stimuli only have their weights updated, and those which do not respond to the strongly to the input stimuli, they do not participate in this weight adjustment process. Okay, so that is why it is known as competitive learning. We are comparing those neurons which are strongly responding to the stimuli with those neurons which are not responding to the input stimuli. Okay, so that is why this type of learning is known as competitive learning. So option A is your correct answer. So is this clear? So more you can read from your lecture note about Hebbian learning and competitive learning. These are the two forms of unsupervised learning. Okay, so this I am not discussing in detail here. Okay, so let's move on to the next question. The log sigmoid transfer function for an input variable L is representing by which of the following equation? So guesses for this?
Yes, sir. Last D answer.
D. Any other guesses? Okay,
No,
so
no, sir. No, sir. D.
okay, so there is a confusion between A and D. Okay, so very nice. So
No,
that,
sir. It's clear D. Sir.
yeah, yeah, okay, okay, I understand. This type of confusion will happen in exam also. So what happens is that this you have to learn that 1 by 1 plus e to the power minus alpha L, right? And the one is your doubt is 1 by 1 minus e to the power minus alpha L. So always what I say is always you memorize the tan sigmoid transfer function. Which among the two is your tan sigmoid function? Your tan sigmoid function is none of the two are tan sigmoid function. If tan sigmoid function you have to memorize, your tan sigmoid function is actually e to the power e to the power plus alpha L minus e to the power minus alpha L e to the power e to the power plus alpha L plus e to the power minus alpha L. So always remember that your tan sigmoid function is less than 1. So how your thing could be less than 1? If x by y is a term, it can be less than 1 only if your x is less than y. Okay, so that is why your minus thing will always be at the top, and plus thing will always be at the denominator. Means your denominator must be heavier than your numerator. That is how your tan sigmoid function will be lesser than 1. So this log sigmoid function you can probably see from this tan sigmoid function. Only you have to replace the numerator with 1 and denominator with this e to the power alpha L you have to replace with 1. Okay, so by this you can memorize your log sigmoid function. Okay, so answer D is your correct answer. So is this clear whatever I have told? Why I have told this? Because you always remember tan sigmoid function, and from tan sigmoid function you can basically remember this log sigmoid function. Okay, and tan sigmoid function is always lesser than 1. So lesser than 1 means your your denominator must be heavier than your numerator. Okay, so plus sign will be in the denominator and minus sign will be in the numerator. Okay, so this is how you can memorize. Okay, so D is the right answer. Now question number 7. In supervised learning, the incremental change del w in any of the weight w is given by the following equation. This is the equation, this you all know, it as the learning rate, E is the error. The negative sign used to signify the fact that if del E by del w is greater than 0, in the next iteration the weight needs to be, I want everyone to guess this. So am I audible? Am I audible?
Yes, sir.
Okay, so
Sir, it also decreases W, but the same answer in B and D.
okay, same answer in B and D. Okay, so okay, no problem. If same answer is written in B and D, then it can be B and D both. Okay, I think there's a printing mistake, or there is a mistake here. This would be something different, but okay, B and D. Okay, B. So yeah, so I have told you this graph. Okay, so whatever I have told you is that when you are E with W, that is W is your weight, and error you are calculating, this is your, let's say this is your learning rate. So when you are searching this, you can see that del E by del W, or your slope is positive, that means del E by del W is greater than 0. Okay, positive slope. But greater than 0 or positive slope means if we are increasing W, our error is also increasing, but that we don't want. We want the reverse of it. Okay, so for that we have to decrease W, as del E by del W is increasing or positive slope, we have to decrease with the help of this negative sign, we have to decrease W. So B and D is your right answer. So I think there is some mistake in the D option here. So B and D is your right option. Okay, so is this clear?
Yes, sir.
Okay. Now for a given function fj, this is this is what type of function. This is your log sigmoid function, and the derivative of fj with respect to j can be represented as. So these are your options. So anyone, any guesses for this? Okay, Murugesh is telling here. Okay, so let me tell you, this is a simple differentiation question, but why is this question asked here? That is important for you to understand. That someone was telling that will that big numerical will come in the exam or not. That big numerical will not come in the exam, but what you can see is here your differentiation is used, right? Differentiation is used because this is your, let's say this is your transformation function, and when you will be reaching from here to this weight W, here from this weight W or weight V, you have to differentiate this two thing. Okay, so that is why differentiation is used. So that is how you would be asking question in your exam, like differentiated. Okay, so you would not be asked a big question, but you will be asked a small question from that one. Okay, like differentiation and etc. So yeah, differentiation, it's very easy. You can do this yeah. So it is actually 1 plus e to the power minus z to the power 1. Okay, to the power 1, sorry, to the power minus 1. So you know that x to the power n, how it is differentiated? It is differentiated by n x to the power n minus 1. So minus 1 1 plus e to the power minus z to the power minus 2. Okay, now e to the power minus z also we have to differentiate. So e to the power minus z is e to the power minus z into minus e to the power z. So you will be getting this thing. Okay, e to the power minus z at the top by 1 plus e to the power minus z whole square. Okay, and now you have been asking you have been asked your answer to be in this form. Okay, so you have to check one by one. So if you will take this away, that is 1 plus e to the power minus z into e to the power minus z plus divided by 1 plus e to the power minus z. Okay, so this thing is f to the fj function. Okay, this thing your fj function. Now about this thing you can write as 1 minus 1 by 1 plus e to the power minus z. When you will solve this, you will be getting this thing. Okay, so this is what 1 minus fz. So your answer is, correct answer is A. Okay, so is this clear? This is your simple differentiation. So I hope this is clear to all of you. Okay, so answer is A. Okay, so this type of question could be asked in your exam. Okay, so let's move on to the 9th question. For the same size of training data as input, the fastest learning technique is supervised training with gradient descent error correction.
Yes, sir. Option A, sir.
Yeah, option A, absolutely right. So steepest descent gradient descent error correction or steepest descent error correction with supervised training is the fastest among all the four. Okay, so option A is the correct answer. You can learn more about this in your lecture notes about Hebbian technique, stochastic method. Okay, so this thing you can read more in your lecture note. So question number 10, which of the following is not a hybrid?
Option D, sir. Parallel hybrid system.
Sir,
Option D. Okay,
sir, actually,
yeah, tell.
sir, sir, actually, in the previous questions,
Yeah,
Hebbian rule is under unsupervised. No.
yeah, unsupervised. So it is given in the option, so it is wrong. So no problem, this is actually wrong thing, so not a problem. Okay,
Okay, okay.
okay. So yeah, so someone was guessing D. Any other guesses for this? So yeah, so I have discussed you, there are three type of hybrid system. One is embedded hybrid system, second is sequential hybrid system, the sequential, auxiliary, and then embedded hybrid system. Okay, so this parallel hybrid system is not a hybrid system. So this this is a hybrid system, this is a hybrid system, this is a hybrid system, this is not a hybrid system, and it is written in the question which is not a hybrid system. So parallel hybrid system is not a hybrid system, so option D is your correct answer. Okay, so is this clear? I think it is clear, that is a direct question. Okay, so let's move to the question number 11. In which of the following one technology caused the other technology, subroutine technology, subroutine to process or manipulate information needed? So any guesses for this? I have discussed in the when I was teaching the hybrid system. So any guesses for this?
Sir, auxiliary hybrid system. Option
Yeah,
C.
Murugation is telling B, I think. Yeah, and someone is telling C. Other from this? Any other guesses? Okay, so parallel hybrid system is not a hybrid system, so this is wrong. Now about this three. Okay, so what we do is in sequential hybrid system is the input of one technology will be the output of one technology will be input of the next technology, or we are using pipelining thing. Okay, so this is your sequential hybrid system. Auxiliary hybrid system, what we do is one technology calls other technology when it is needed for that technology. So this auxiliary this statement is true for this auxiliary hybrid system. And embedded hybrid system, we do the complete fusion. So C is your correct answer. Okay, this C is your correct answer. So any doubt about this? I have already discussed about this. Any doubt about this? So I hope this is clear why it is not A. Embedded system, what we do is we completely fuse the technologies. Okay, so it is option A is not correct, C is the correct answer. Okay, so let's move on to the next question. Fuzzy genetic hybrid system is A is fuzzy logic in parallel with genetic algorithm, B is fuzzy logic control genetic algorithm, C is genetic algorithm control fuzzy logic, and D is none of the above. So any guesses for this?
Yes, sir. Physiology control genetic algorithm.
Yeah, B. Murugation is also telling B. Any other guesses? Anyone else? Okay, no problem. So this thing I want to discuss is that, right, whenever this is written FLGA, what is the difference between these two, FLGA and GAFL? These two are not same. Okay, GAFL and FLGA if it is written, and GAFL it is written, these two are not same, these two are different. Now in this FLGA, what happens is your system is your GA. Okay, FL is used FL is used to tune in some parameters only. Okay, now if I am talking about GAFL, then FL is your true technology, and GA is used to tune some parameters of your FL. So this is the difference. So here it is asking fuzzy genetic hybrid system. So genetic system will be your main system. So your answer would be first, fuzzy logic in parallel with genetic algorithm. This is not correct. Fuzzy logic control genetic algorithm. So yeah, your answer should be genetic algorithm should be your main algorithm. Okay, so fuzzy logic is only tuning some parameter or controlling something. Okay, so B is your right answer. So is this clear what I have told you? More detail you can read from your lecture note, but this is the concept. Whatever that is written in the last, that is your main algorithm, and whatever that is written in the written in first, that is used to tune in some parameter. Like we use name and surname. Okay, so our surname is actually our main name or our family, right? And name, by name we are just tuning our parameter. Okay, so that way you can draw an analogy. Okay, so is this clear what I have told you?
Sir,
Okay, so
sir,
let's,
one doubt, sir.
yeah, yeah,
Sir, actually, we are tuning the PID controller by using the genetic algorithm.
yeah, yeah.
Yeah, in that, first we have to tune the genetic algorithm, then we have to run the fuzzy logic.
Okay, so
That is the question, sir.
I don't exactly know about that working of that PID GA algorithm, so that I didn't know, but this is the thing. Okay, this is the main concept actually. Okay, so
Okay, okay, sir.
more
Okay.
thing you can read, and okay, we don't have a time also, but that you can read in deep also, but everywhere it is written like this. The second name is your actual algorithm. Okay, and first name is used to tune actually. Okay, so let's move on to the next question. Both fuzzy logic and artificial network are soft computing technique because both give precise and accurate result. These artificial neural network give accurate result, but fuzzy logic does not. C is in each no precise mathematical modeling of the problem is required, and D is fuzzy gives exact result, but artificial neural networks do not. So any guesses for this question? Yeah, Parv Yadav is telling C. Any other guesses? Okay, so let me tell you the answer. So in the first class only, when I have discussed about soft computing, I have told you soft computing. In soft computing, we do not need precise mathematical modeling of the problem. Okay, so let's check by option by option. Both gives precise and accurate result. So the thing with soft computing is that it does not give you precise result. Okay, your more precise result can be obtained with your hard computing. Soft computing do not give that much precise result, but still why we are preferring soft computing, because the process is very fast. We do not need any mathematical modeling of the problem. Okay, so that is why soft computing can be used in your real life problem better than your hard computing. So this is not correct. Artificial neural network give accurate result, but fuzzy logic does not. So this is also not correct. This is correct, I have already told you. And fuzzy gives exact result, artificial neural network does not. This also we cannot say this. So option C is your correct answer. Okay, so soft computing, again I am telling. So what happens in soft computing is that we do not get precise solution, but still we prefer soft computing over hard computing is that we do not require any mathematical modeling of the problem. Okay, so that is why we prefer soft computing. So this is the thing. So fuzzy logic and artificial neural network are tools of soft computing. Okay, so is this clear?
Okay, sir.
Now question number 14. As per neural network terminology, the term feed forward and back propagation indicate what? Okay, so option A is forward propagation of input information from input layer to output layer, and back propagation of input information from output layer to input layer. B is forward propagation of error from input layer to output layer, and back propagation of error from output layer to input layer. C is forward propagation of error from input layer to output layer, backward propagation of input information from output layer to input layer. And D is forward propagation of input information from input layer to output layer, and back propagation of error from output layer to input layer. So any guesses for this? Yeah, Parv is telling D. Any other guesses? Yeah,
I
Murugesh.
think that's D is the correct.
Yeah. So let's read all this. So what happens in our feed forward and back propagation neural network is that feed forward means our information should go from our information should only go in forward direction, that is from input layer to the output layer. Okay, and back propagation of error is means that our error should go from our error correction should go from output layer to input layer. Okay, so in the question also you can see that when we are updating our weights, we are actually going from this here to our weights. Okay, so our error should always move, or our error calculation should always move from output layer to the input layer. Okay, so this is the thing. So answer D is the correct answer. Answer D is the correct answer, that is forward propagation of input information from input layer to output layer, and back propagation of error from output layer to input layer. Okay, so D is the correct answer, and all the answer are false. Here it is false because back propagation of input information, so this is false. Back propagation, if input information is also back propagated, then that type of network is known as recurrent neural network. Okay, not feed forward neural network. So this is wrong. Forward propagation of error is not forwardly propagated, so this is wrong. Forward propagation of error, again this is wrong. Okay, so this is the thing. So let's move on to the last question. A batch mode of training is generally implemented through the dash in error calculation. So any guesses for this? Minimization of individual error, maximization of individual error, maximization of mean square error, and minimization of mean square error. So any guesses for this? Yeah,
Actually confused in C and D.
yeah.
Maximum or minimum.
So error, okay, so you are confused between C and D. Okay, so error cannot be maximized, right? We are all only minimizing the error. Okay, so that is what we do in training. So C option can't be correct. Okay, so C option cannot be correct. Similarly, maximization of individual error, B option cannot be correct. So your confusion should be between A and D. So what happens in there are two type of training. One is incremental training and one is batch mode of training. Okay, so incremental training, what we are doing is we are calculating the question that we have done, that is incremental mode of training. Incremental mode means we have only checked for one iteration, but what happens in batch mode of training is that okay, so what happens in batch mode of training is that for all the neuron, like there are n number of neuron in the output layer, for all the neuron we do this calculation. Okay, that is error is calculated for all the neuron, that is batch mode of training. Okay, so this is known as mean squared error. Okay, so why it is called as mean squared error? This is the error, you can see this is the predicted this is your predicted output from the neural network, and this is your target output. Okay, so we are reducing your predicted output from target output, so that this is simple error. Okay, we are squaring this, so that this is squared error. Now in this batch mode of operation, what we do is we find the mean of all this error. Okay, so this is mean squared error, MSE. So in batch mode of training, we are minimizing the mean squared error, not individual error. If this is an incremental mode of training, then we are minimizing the individual errors. But in batch mode of training, what we do is for all the neurons, we are minimizing the error at once, that is mean squared error. Okay, so D is the correct answer. So is this clear?
Yes, sir. Clear.
Okay, so by this we had ended our session. So any doubt for today's session, you can please ask.
Just say something about the exam.
Exam, I am not taking the exam, right? I am just a problem solving TA, but I can tell that all the lectures, whatever I have told you, what 15 question for 8 weeks, I have given you all the 15 question for 8 weeks, right? And I have also told you the approach, how to solve the questions, right? So by that, this video only, if you will see, plus please download all the slides. The slide link will be also in the problem solving session that page, that all the links are updated there. So kindly go through all these slides, and lecture notes, if you can go through all the lecture note, that will also be useful. So by this should be your strategy for the exam. Other than
Sir,
that,
will these slides will also be available?
yes, the slide are already available, right? In the problem, in that NPTEL portal, there will be below called problem solving session written. Okay, so in this problem solving session, when you will open this, in the middle of the that middle column, you will find a folder over there. Okay, link of a Google folder. There when you will
Yes, sir, got it.
there when you will check, you will get all the 8 week slides. Okay, so
Okay, thank you so much.
any other doubt regarding anything?
Sir, there are some really bulky formulas also present. Should we like memorize them?
Bulky formula, give me some example. uh, so I will tell you.
Especially in like 5 and 6 weeks, we have some big formulas there, and
So I think you should focus more on what type of question are asked with that formulas. If the question are not asked with all this that bulky formulas, so you do not need to remember all this. Okay,
okay, thank you
what
so
type of
much.
question have been
I think so. We'll
asked?
let this in exam.
What can you please repeat?
I think this type of question will let this in exam.
Yeah, similar type of question you can expect. Please go through assignment, all the assignment problem, as well as all the problem that I am discussing. Okay, you please practice this type of exam, and related theory, you please have a look at that. Okay, because some of the theory questions, I usually say that you please see your lecture note. So in that, please see all the theory from your lecture note. Okay.
Okay, sir. Thank you.
Okay, so any other doubt regarding today's session you want to ask? We still have 9 minutes. So anything you want to ask, you can ask.
Sir, can you share any idea related to research to apply the soft computing technique toolbox?
Yeah, actually, I am myself a research scholar, and I am doing my research on related to neural network in agriculture. Okay, so any sector you can do your research. Like what my research is, I am doing image processing by neural network of capsicum vegetable. Okay, so this type of research you can do. So there is a popular technique called RCNN YOLO. Have you ever heard about this YOLO?
No, sir.
You only look once. I am writing in the chat box. You can search this YOLO. Okay, YOLO. So YOLO is a technique in which you are training a model. Okay, you are training a neural network model, and when your model is fully trained, So it applies computer vision and do real time inference of images. Okay, like when you will be building a model, then that model will be inferencing your data, okay, in real time. So you can search about YOLO. So this is a type of research. So like this you can apply GA in different optimization process. Like any engineering data, you will have many input variables, you will have many output variables, so you can optimize your results by GA. And fuzzy logic is used, I think, in that robot application. Like when you are path planning your robot, so there you can use that application, because there your the questions also I have discussed, you would remember that how a robot will take decision. Okay, so that Mamdani approach and that Takagi Sugeno approach, so that you can apply in your research. So research is a broad term. You can probably think of anything and apply your soft computing. Okay, is it okay, Murugeshan?
Yes, sir. Yes, sir. Thank you, sir. Thank you very much for sharing your research ideas, sir.
Okay.
Thank you. Thank you so much, sir.
So any other question? So okay. So by this, I think I should terminate this session. So it was a pleasure to be with all of you for 8 weeks. I hope I can try to I have given you something. By that you will excel in your life, and all the best for your future. Okay.
Thank you, sir.
Okay. So bye bye everyone.
Thank you very much, sir.
Thank you so much, sir.
All your all 8 session is very useful for us, sir,
Yeah, yeah.
in a different way of
And again
thinking our
again
knowledge.
I am telling you that the big question that I have given you, like fuzzy logic also, genetic algorithm also, and today also, that big question will not exactly come in exam, but you can get the idea that how to apply how to apply in your computer program. Okay, so if you will design a computer program in future or anything, there you can understand the logic better by big questions. Okay, so that is my motto for discussing the big questions. Okay.
Okay, sir.
Okay.
Thank you, sir.
Okay. So
Thank you, sir. Thank you so much.
okay, so bye everyone, bye, all the best for your exam. Okay.